Hello all and welcome to Station 204. Now for your space news today, November 20th, we have got some very expensive seats, a nicer observation of the sky, and the kickoff of a series of very complicated spacewalks. But of course, as we always like to start off space news, let's get right into space traffic. We start out in the asteroid belt, where Japan Aerospace Exploration Agency's Hayabusa 2 says sayonara to asteroid Ryugu, firing thrusters at 0124 Universal Time on November 13th to achieve an escape velocity of, yes, 9.2 centimeters per second. Now, over the next few weeks, Hayabusa 2 will methodically move away from Ryugu before firing up its 4 ion thrusters to propel it on course to Earth, where samples collected on the surface of Ryugu will land back on Earth in a special capsule in late 2020. A Kuaizhou 1A from the China Aerospace Science and Industry Corporation's X-Space Technology Corporation launched at 0340 Universal Time on November 13th at the Jiuquan Space Center. On board was the Jilin 1 Gaofen 02A spacecraft, a commercial Earth observation satellite for the Chinese Academy of Sciences, which was successfully placed into orbit. And a mere 3 hours later, a Long March 6 rocket lofted 5 Ningxia 1 remote sensing detection satellites from the Taiyuan Space Center at 0635 Universal Time on November 13th. Successfully placed into orbit, very little information is available about the Ningxia 1 satellites, but previous press releases imply that they are used for signals intelligence. China is absolutely smashing the end of the year with its launch cadence, and another Kuaizhou 1A from the China Aerospace Science and Industry Corporation's X-Space Technology Corporation launched at 10:02 and 02 seconds Universal Time on November 17th at the Jiuquan Space Center. 2 satellites were successfully deployed, with the only information about them being that they will be used for Ka-band communication tests. And hopefully my Mandarin this week was a little better than it usually is. And here are your upcoming departures. NASA's Office of Inspector General, or OIG, is tasked with something that is well outside of the scope of the usual cutting-edge spaceflight technology that we're expecting to come out of NASA. They audit NASA. Yep, they look at NASA's budget books and figure out where the money's going and if the money's doing what it's supposed to be doing. Now, I think that stuff like this, the politics of spaceflight and getting into the minutiae and the tiny bits about budgets and other things like that, is just as fascinating as the technological development itself. There's a real story to be told there, and OIG, well, they dropped a report recently, and it's about commercial crew, and some people are very upset about it. The main idea behind NASA's commercial crew program was to allow for American astronauts to once again be flying to the International Space Station on American spacecraft. The retirement of the Space Transportation System in 2011 marked the beginning of reliance on Russian Soyuz rockets and spacecraft to ferry American astronauts to the outpost in low Earth orbit. NASA has had to pay Roscosmos for seats on its Soyuz to the tune of $86 million per. Now, I don't have that kind of money, but NASA does, and it spends that kind of money in order to make sure that American astronauts are headed to the International Space Station. And commercial crew is supposed to lower that cost, but it would appear that one company didn't get that memo. OIG looked at the commercial crew transportation capability contracts from 2014, where Boeing was awarded $4.3 billion and SpaceX was awarded $2.5 billion. This covers 6 flights with 4 astronauts on board, up and down to the International Space Station. OIG then subtracted reported costs for the development of the 2 spacecraft, which Boeing's Starliner cost $2.2 billion, and SpaceX's Crew Dragon came in at $1.2 billion. And after some more math, the report drops the hammer. SpaceX's Crew Dragon costs roughly about $55 million per seat, which is definitely well below the $86 million per seat on a Soyuz. But Boeing's Starliner, turns out it's $90 million per seat. So a program that was supposed to be cheaper has actually ended up being 5% more expensive. And as you can imagine, Boeing has publicly slammed the OIG report. They cited that Starliner needed more funding as it had to start from scratch, which I suppose is a good point considering Crew Dragon draws on quite a bit of what was developed for Cargo Dragon. In addition, Boeing cites an air quotes fifth person close air quotes with the amount of cargo a Starliner will be flying on each flight to the International Space Station, which to me is a pretty lame, eye-roll-inducing point. And let's not even get started on the $287 million that Boeing received to handle an 18-month gap that didn't happen, because would you look at that, no one has flown a crew yet. NASA, of course, also doesn't agree with the OIG's assessment of the costs of commercial crew. Now, just throwing this out there as a hypothetical, if NASA had paid SpaceX the same amount that they paid Boeing, Congress would have probably looked at the commercial crew program and said, well, that's too expensive, and not funded it, and we still wouldn't have commercial crew. In addition to that, if NASA gave Boeing the same amount of money that they gave SpaceX, Boeing probably would have laughed in their face and then not made Starliner, which means that we wouldn't have had commercial crew. Holy sh**. Politics is wild as hell in spaceflight, and maybe just as difficult as the engineering side as well. And there's a lot of action happening on the International Space Station over the next few weeks, as 3 more spacewalks are planned to start repairs to the Alpha Magnetic Spectrometer, high-energy particle physics instrument mounted on the outside of the ISS. The first spacewalk, which happened November 15th, lasted for 6 hours, 39 minutes. Kicking off the most complicated series of spacewalks since Hubble repair missions, Italian astronaut and current International Space Station commander Luca Parmitano, along with American flight engineer Drew Morgan, spent their time setting up tools and equipment for the upcoming spacewalks. This included removing a protective debris shield and chucking it overboard. Zip ties and thermal blankets were also moved, helping prep the Alpha Magnetic Spectrometer to be repaired, which is a difficult task considering it was not designed for any kind of repair at all. Parmitano and Morgan worked well ahead of schedule and completed several tasks that were originally planned for the spacewalk on November 22nd. Planning for this series of spacewalks began in 2015, and the fruits of that 4 years of labor are paying off. There may be a 3rd and 4th spacewalk depending on just what exactly ends up completed during this Friday's spacewalk, which, by the way, on November 22nd, it's expected to start around 11:30 Universal Time. So jump on NASA's website, they stream it, and you can watch it live. And to talk about this week's space weather and a little bit about water in Europa, here's our own Dr. Tamitha Skov.
Just as space weather begins to worsen for amateur radio operators and emergency responders, it picks up for aurora photographers. As we switch to our front side sun, you can see that bright region. That is a solar cycle 25 sunspot. That's region 2752. And you can watch it kind of fizzle and fade out as it rotates across the disk. You know, these new cycle sunspots, they don't last very long yet, but they're getting stronger. But just above that region, you can see that decent sized coronal hole. That is going to be bringing some fast solar wind here in the next day or two, and it could bring aurora down to mid-latitudes. The jury is now in. A new paper just out in Nature Astronomy has confirmed that Jupiter's moon Europa does indeed spout water vapor plumes from the oceans beneath its icy surface. Although NASA's Hubble Space Telescope has long spotted indirect evidence of these water plumes, until recently they only had a smoking gun. Now, along with observations made over the course of 17 days in 2017 from the Keck Observatory in Hawaii, researchers struck gold. Water. On April 26, they unexpectedly received a strong signal, a special kind of infrared light that can only be emitted by water. And there was quite a bit of the stuff too, about 2,100 metric tons according to the researchers' estimates. That's almost enough to fill an Olympic-sized swimming pool. Now, along with the other observations, this massive amount of water is proof positive that this indeed is a water vapor plume shooting out of Europa's surface, as no other known process in the Jovian system can account for it. Not even Jupiter's intense radiation belts could strip enough water molecules from the surface of Europa to release that much water vapor in its atmosphere. Not to mention Jupiter's radiation belts, they would create a continuous release of water, not just one massive plume. So understandably, this news has got astrobiologists talking. In the search for life on other worlds, these water plumes are like little messengers from heaven, shooting samples of possibly habitable environments right out into space for us to fly through and measure using orbiting spacecraft. Who needs a lander? In fact, this is exactly what the NASA mission Europa Clipper is betting on. Scheduled to launch in the mid-2020s, it will orbit Jupiter, having many chances to get up close and personal with a possible plume through dozens of Europa flybys. Clipper's aim? To chart the moon, its ocean, and search for spots where a potential life-hunting lander could touch down on the icy surface in the future. And if the mission team members learn enough about these water vapor plumes in the coming years, Clipper might just wind up zooming right through one. Now, what would it mean to you if we found life on Europa? For more details on this week's space weather, including when and where to see aurora, how your GPS reception will fare, and how amateur radio is doing, come check out my channel or see me at spaceweatherwoman.com.
If you're on Twitter as much as I am, you've probably seen the astronomical community is kind of having a little bit of a freak out about SpaceX's recently launched batch of Starlink satellites. There's been lots of images of fields of view being studied that end up having them zipping straight through it and absolutely wrecking the data being taken. Now, a lot of people are saying that we should just launch more space telescopes. It's not that easy. But I mean, that's for a discussion a little bit later down the way. But there is a space telescope that we do want to talk about here called NICER. It is up on the International Space Station. And to talk about a recent high energy result from it, here is Manju Bangalore.
So Jared was just talking about Starlink, and I think that global access to the internet is a fundamental right. But I also understand why astronomers might be a little angry. Perhaps the future of astronomy lies in a compromise. In the near future, astronomers may be able to fully rely on space-based astronomical platforms to collect data and observe the universe. The NICER telescope, sitting outside the International Space Station, observed something pretty incredible back in August. The neutron star Interior Composition Explorer observed X-rays shooting out of a pulsar in the Sagittarius constellation 11,000 light-years away. Pulsars are condensed cores that are rapidly spinning after the death of a massive neutron star. This pulsar, called SAX J1808, draws on its nearby brown dwarf star for hydrogen gas and then pulls it into an accretionary disk. Every now and then, the accretionary disk becomes too dense for itself and the hydrogen gas ionizes. The pressure and temperatures increase, causing nuclear fusion, and after a while, a thermonuclear burst blasts across the surface of the pulsar. This binary system is especially unique for two reasons. One, it's a millisecond accretionary pulsar. Now, neutron stars are rare. Pulsars are even rarer. Accretionary pulsars are even more rare, but millisecond accretionary pulsars, only 13 of them. And we happen to catch one of them releasing a massive, massive burst. But the more important reason is that the brown dwarf star orbiting the pulsar only takes 2 hours to complete its orbit. So basically, it can complete 600 revolutions by the time you finish a Lord of the Rings movie. I also want to know, did other objects around the pulsar survive the supernova explosion, and could they be exoplanets? At the beginning of the burst, the brightness decreased for less than a second. And in this short time, scientists think that the star built enough energy to push its hydrogen layer into space. In 20 seconds, the X-ray burst released as much energy as the sun releases over the span of 9 days. To date, it is the brightest set of X-ray pulses NASA has ever observed. What a brilliant sight.
And of course, we want to give a huge shout out to all of the citizens of tomorrow. Without your help, we wouldn't be able to make any of this possible. No news, no letting off steam, absolutely nothing. So if you got something from us and would like to give something back, you can head on over to youtube.com/TMRO/join, and you can always head over to community.tmro.tv to find other ways to help. As always, hitting that subscribe and notification button, liking, sharing, and getting us in front of as many people as you can helps make it possible for us to pursue the core of our mission here at Tomorrow, which is to get everyone excited about space. So until the next space news, keep exploring.